Welcome to one of the coldest places in the universe.
What? In an office park in a Vancouver suburb?
Meet physicist Jordy Rose of D-Wave Systems, who claims they've used cold to build the world's first commercial quantum computer.
It's C-3PO's wedding cake.
This is a quantum computer.
And then what does that mean?
You have to rethink the way you think about computers to wrap your head around it.
Remember that quantum strangeness below 2 Kelvin? Inside this giant refrigerator, Rose's team keeps a few atoms 100 times colder, all to harness those weird abilities to make a new kind of computer.
So let me get this straight. This entire company, this entire building, this entire meat locker, this entire million-dollar apparatus is all designed just to make that tiny chip cold.
Yes.
What does the cold have to do with the computing?
In quantum mechanics, the properties that we're trying to harness are very easily washed out by the movement of the atoms in the processor. As you go down the plates through 4 Kelvin, 0.7, 0.1, at each stage, we want to remove the wiggling of the atoms so that they just calm down, take a seat on the couch, relax. And when they do that, these wonderful, powerful, magical properties that exist in quantum mechanics blossom out.
Quantum properties like being in 2 places at once. That magical ability allows D-Wave to program their computers in a very special way.
The fundamental piece of information storage in this is a device called a qubit.
Like the biblical measurements?
Very unlike the biblical measurement.
A qubit is the quantum version of a bit, the basic unit of information. In a regular computer, a bit can be either a 0 or a 1. But a quantum bit can be either a 0 or a 1, or both 0 and 1 at the same time. This gives it exponentially more power than a conventional computer, which would use 8 bits just to store a single number between 0 and 256. In a quantum computer, 8 qubits can store all 256 numbers at once.
The real kicker is when you have a lot of these bits. The total number of possibilities doubles every time you add a bit.
So, while 10 qubits can store 1,024 numbers, 11 qubits can store 2,048 numbers. When you get to 100 qubits, you can store 1,267 octillion, 650 septillion,
600 sextillion, 228 quintillion, 229 quadrillion, 401 trillion, 496 billion, 703,205,000,
and 376 numbers.
So by the time you get to about 500 bits, you have more possibilities than there are atoms in the visible universe.
Wow.
What this means is that a quantum computer can tackle problems on a scale beyond any conventional computer. From weather prediction and air traffic control to forensics and finance. Problems on this scale are everywhere and have simply outstripped our abilities to solve them. And though some have questioned their claims, there are buyers. D-Wave's first customer, aerospace giant Lockheed Martin. Their F-35 fighter plane is incredibly sophisticated.
And we have touchdown! Whoa. This is a fairly software-dependent little plane. Yes, it's got about 9 million lines of code.
9 million lines of code?
Those 9 million lines of code can land a plane on a carrier, evade enemy radar, and hover like a helicopter. Trouble is, no conventional computer could ever check that software for errors without an army of engineers.
Is it just too many variables to all consider at the same time?
That's exactly right. If you have a million, suddenly you can't manage it with any computer on Earth.
Which is why now NASA and Google partnered to buy a quantum computer too, in hopes of better finding habitable planets and speeding up search.
Can I have one?
How much money you got?
Not enough.